Okay, for this section, we're going to talk about solving quadratic equations and what that means. Just a quick definition here. This is a quadratic equation, and this is a quadratic function. As you can see, there's a 0 in for y here, and there's a reason for that. The solutions to of a quadratic equation are the x-intercepts of its related quadratic function. The x-intercept is when y equals 0. So for any of these, when it says to solve for the quadratic equation, you can put a 0 in for y, and then you solve for x. The x in a graph, or the solutions in a graph, are where the x-intercepts take place. So we're going to show you kind of what that means here in these graphs. All right, so a quadratic equation can have two solutions, one solution, or no real solutions. For the most part, once you get into a lot of the equations, you'll see that they'll have two based on the problems that we give you, but we're going to talk about what the difference is between the three. So the solutions of quadratic equation and the related x-intercepts are also called the roots of the equation or the zeros of the function. So down here you see we would work, and I would kind of challenge you to say draw a graph that has one solution. Well, any type of graph that only hits the x-intercept, which is this line right here, once, would only have one solution. So a U-shaped graph where it just hits one spot on the x-intercept would only have one solution, which would be that. You could have it go this way as well, where it's only hitting one spot, but that would be an example of a graph that has one solution. All right, a graph that has two solutions means it's going to have two x-intercepts. So for example, it might be something like this, where it crosses in two spots. Anywhere that where the parabola crosses that x-intercept twice, those would each be solutions to that graph. There could also be a situation where you have no solutions, and that means that it would never cross the x-intercept. You can see here's the x-intercept, or it could be something like this. That would be examples of graphs that would be considered to have no solution. Okay, so how do we graph these? So we can graph based on what we did previously by finding the vertex, picking points and the sides, but if we're going to solve, we kind of already have learned how to do this, but I'm going to show you another tool that you can use when identifying the solutions of a graph, and that is by going to Desmos.com. If you have a graphing calculator, a lot of times you can plug these in, but we're going to show you how it works on a graphing calculator as well. So you're going to graph it, and then note the x values where it crosses the x-axis. So if I go to our page, I posted a graphing tool on Desmos.com. And all right, so here's a graph, and now all we have to do is type in our equation here. So I'm going to go back to the notes just to see. So we have x squared minus 1. So I'm going to go to this. I'm going to type in x squared minus 1. So x squared minus 1. And now where you would hover these over would be your solutions, because that's where they cross the x-intercept. So you can see the x value is -1 here, and the x value is +1 there. And we have a vertex of 0, -1. So if you were going to go through the long way of doing this, now if you remember that the vertex, when we don't have a C, is usually at the origin, and then this either shifts it down or up based on that. So this would be our vertex in that one. And then we know that it was -1 and 1 that it was passing through, so your graph would look like that. All right, so there's one way of doing it in graphing. So just with this one, you can go ahead and type that. Maybe pause this, type that into Desmos.com and see what your answer is. All right, I'm going to go ahead and put the vertex here, because again, there's no middle term with just the x, so we know we go up 4 units. 1, 2, 3, 4. That's going to be the vertex. And this is going to be, knowing that this is positive, should be a no solution type problem because it's going up. So I'm going to go over to the calculator. So 2x squared plus 4 I'm going to change this. So 2x squared plus 4, and you can see that it is up here. Now, this would be an example of no solution because you can see that the graph is going up and it never crosses the x-axis. I'll jump back to this in one of the examples and show you how it comes out to no solution when we're solving it algebraically. All right, so we can see that this graph is looking like this, and there would be no solutions to that. So the solutions of this one would be plus or minus 1, and this would be no solution. And that's based on solving for graphing. Now, we talked about solving problems by square roots, which is we did in a previous section, so that's basically the exact same way that we're going to do this. So we need to get the equation by itself, and we're going to just solve these algebraically to figure out what the solutions are to all of these quadratic equations. If I type all of these in, if I set them in equal to 0 first and I type them all into Desmos, then I will get a graph. And this one's not set equal to 0, so that would be difficult to do. So over here, you're going to get t squared by itself. I'm going to do that by adding 25 to both sides. So I have t squared equals 25, and then to undo a square root, we take the square, or undo a square, we take the square root of both sides. So this becomes t equals, and then because I took the square root of positive, plus or minus 5 would be my answer. So if I look at this, or if I graph it, if I graph t squared minus 25 on my tool, so t squared minus 25. Now I'm going to put in x here because I think it needs to recognize the x. There we go. So you can see here, I even zoom out, you can see where the bottom is. It shifted down to 25 because that's our c, and this is negative 5 and 5. So that matches up with our problem. All right, so going back here, we're going to set this one up. I would subtract 32 from both sides. So 2g squared equals negative 32. You divide by 2. So g squared equals, so this would equal negative 16, and then I take the square root of both sides. Now if you remember, anytime you take the square root of a negative, you can't do that. It's impossible. But I'm going to go over here and I'm going to type that in so I can show you what I mean. So negative 16, oops, I got to take the square root of that. Into that first. Negative 16, and you can see it says undefined. So that would be an undefined or no solution for this problem. Now if I type this in, you'll see to the graphing calculator, so I'm going to call it x squared plus 32. So I'm going to go to this graph again. So 2x squared plus 32. And I'm going to zoom out. So you can see that the graph is opening up and it's never crossing over this x-axis. So that makes sense. Those kind of go together. All right, so this would be no solution right here for that problem. Now over here, I can't type this in to graph it because I would have to set it equal to 0, meaning I would subtract 12 from both sides and I have 3n equals 0. So that's one way of doing it. But if I'm going to do it this way, so subtract 12, so 3n squared equals 0, divide by 3. You can already see the answer here. So n squared equals 0, take the square root of 0 is just 0. So in this case, our one solution to this is 0. So this was a 2 solutions, positive and negative 5. This was a no solution problem because that graph never crosses the x-axis. And this is, it crosses at 0. So if I'm going to graph this and check it, I'm going to subtract 12. I'm going to work it backwards and set it equal to 0. So I can use 3x squared equals 0. Because if I subtract 12 either way, that's going to cancel out. So if I go to 3x squared equals 0 on my calculator, 3x squared it's assuming it equals 0. You can see that it only touches that one point, which is 0, 0. So that is our one solution for that problem. So that is that section of being able to solve for quadratics. You can use the Desmos calculator. If we don't give you a graph and it's just to solve for it, you're just using the square root rule to get rid of the square and figure out what your solutions to that equation are.